Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic name is Problems on Mutual Exclusive Events. Actually, conditional probability for mutually exclusive event, that is stating the probability of event A and given another event B has occurred. The conditional probability for two independent events B has given A is denoted by the expression that P of B given A. Now it is defined by using the equation is that probability of B given A is equal to probability of A and B divided by probability of A. Now again we have to redefine the equation using the multiplication rule, that is probability of A and B is equal to 0 and the probability of B given A is equal to 0 upon P of B. That means probability of B given A is equal to 0. That is showing the mutually exclusive. Now we will see the problems on it. Now we have to find out what is the probability of a die showing a number 3 or number 5. Probability of 3. The probability of getting a number 3 and probability of 5, the probability of getting a number 5. That will be probability of 3, it will be 1 by 6 and probability 5, it is the 1 by 6. So, probability of 3 or 5, that means any one, either 3 or 5. So, here we will find out probability of 3 plus probability of 5. We got the probability of 3 and probability 5, that is 1 by 6 plus 1 by 6. 2 by 6. It's the 1 by 3. Probability of a die showing 3 or 5, that is 1 by 3. Now second question is that 3 coins are tossed at the same time. Now we say A as the event of receiving at least 2 heads. Likewise, B denotes the event getting no heads. C is the event getting heads on the second coin. So which of these is mutually exclusive? First, let's create a sample space for each event. Now for the event A, we have to get at least 2 heads. What is saying that A as the event receiving at least 2 heads. We are tossing 3 coins at the same time. So there will be the sample space like head, 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 tail, head, 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 tail, then head, tail, head. Tail, 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 head, tail, 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 head. Then again, so here you are getting the sample space and after that you have to find out the first A events. Sample space for the A. These are your sample space. At least 2 heads means 1, 2, 3 and 4. And A has 4 elements or events in it. That is n of A will be 4. Now after that, in the same way for event B is saying that no heads. No heads means just it will become tail, tail. That is n of B will be 1. Now again using the same logic we can write event C, that is event getting heads on the second coin. Only second coin. 1, then 2, 3 and 4. Again there are 4 events. So n of C is a 4. Now You can observe here n of A is equal to n of B is equal to n of C. So that's why we can say that BC and AB are mutually exclusive since they have nothing in their intersection. Now next question. The likelihood of three teams A, B, C winning a football match are 1 by 3, 1 by 5 and 1 by 9. Find the probability that out of the three teams, either team A or team B will win, either team A or team B or team C will win. None of the teams will win in the match. Neither team A nor team B will win the match. Now probability of A or B will win. That is 1 by 3 plus 1 by 5. It will come 8 by 15. Second one is that probability of A or B or C will win. That is 1 by 3 plus 1 by 5 plus 1 by 9. It is 29 by 45. Then probability of none will win. That is 1 minus probability of A or B or C will win. We have to minus from the 1. Now after that, that is 1 minus 29 by 45. It will come 16 minus 45. Then probability of neither A nor B will win. That is 1 minus P, either A or B will win. And our values are 1 minus 8 by 15. That is 17 by 15. Now next question is that if A and B are two independent events, then A and B is. So here A intersection B naught and A and B both are mutually exclusive events. So here A is equal to A intersection B naught union A intersection B. P of A is equal to P of A intersection B naught plus P of A intersection B. That is P of A intersection B naught is equal to P of A minus P of A intersection B. Now P of A minus P of A into P of B. And here both A and B are independent. That's why P of A intersection B naught. So P of A 1 minus P of B is equal to P of A P of B naught. So both A and B naught are also independent. Next question is that probability of PA, that is 2 by 3, probability of B 1 by 2 and probability of A union B, it is 5 by 6. Then events A and B are. Here you can use the formula. Again probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B or probability of A and B. Now probability of A union B, you have 5 by 6. Probability A you got 2 by 3. Probability B 2 by 3 and you have to find out the probability of A and B. Now probability of, after solving, probability of A and B will be 0. That's why we can say A and B both are mutually exclusive. Now next question is that a card is drawn at random from well shuffled deck of the 52 cards. We have to find out the probability that the card drawn is a king or an ace. As per the definition mutually exclusive events, selecting an S and selecting a king, a well shuffled deck of the 52 cards are termed mutually exclusive events. Assume X to be the event of drawing a king and Y to be the event of drawing an S. And in standard deck of the 52 cards, there exist 4 kings and 4 s. So probability of an event is count of the favorable outcomes divided by the total count of the outcomes. Now probability selecting a king from the standard deck of the 52 cards is P of x is equal to 4 by 52, that is 1 by 13. Then probability of selecting an S from a standard deck of the cards, that is 4 by 52, 1 by 13. Now you have to compute probability of king or S. Here we will use the formula for the mutually exclusive event. Probability of x or y is equal to probability of x plus probability of y. Now probability of x or y is equal to 1 by 13 plus 1 by 13. Here 1 plus 1 divided by 13, that is 2 by 13. Now the probability of selecting a king or an S from well shuffled deck of the 52 cards is 2 by 13. Now next question is that Daniel is trying to understand mutually exclusive event using dice. Now help Daniel understand what is the probability of dice showing 4 or 5. So there are total of 6 faces on a die. So number of outcomes will be the 6. So probability of the die showing 4 is, that means probability of 4 will be 1 by 6 and the probability for 5 will be 1 by 6. Now we have to find out the probability of getting 4 or 5. We are not asking for the 4 and 5. We are asking 4 or 5. So probability of 4 plus probability of 5. 1 by 6 plus 1 by 6. That is 2 by 6. It is 1 by 3. Now next question is that Benny's teacher is teaching them about mutually exclusive events and gave him a deck of 52 cards and asked him to select a red card or a 6. Now we have to find out the probability of selecting a red card or the 6. Now probability of getting a red card will be 26. 26 by 55. We know that the red cards in the deck of cards is 26 and black cards are 26. So probability of getting a 6 and 6 cards are 4. So that is 4 by 52. And the probability of getting both red and the 6 is 2 by 52. Here probability of R or 6. R is a red. Probability of red plus probability of 6 minus probability of red and 6. That is 26 by 52 plus 4 by 52 minus 2 by 52. Now after solving, you will get 28 by 52 and that is 7 by 30. Now Caroline noticed her mother trying to make out the fish to clean the fish tank. And she asked her mother, how many are males and how many are females? Her mother replied that the tank contained 5 male fish and 8 female fish. Now we have to find out the probability that the fish her mother takes out first is a male fish. Now there is a solution. Probability of an event, that is number of possible events divided by total number of favorable outcomes. Here number of male fish are 5. Total number of female fish are 8. So total number of fishes are 13. Now the probability that the fish are taken out is male fish. That is no male fish divided by total number of fishes. Number of male fish, no female fish and the total number of fishes. The probability that fish are taken out is male, that is 5 by 13. Now next question is that a bag contains 8 black pens, 2 red pens, and if pen is drawn at random, what is the probability that is black pen or red pen? Now X be the event getting black pen and Y be the event getting red pen. Now we know that there are 8 black pens and 2 red pens. Therefore, the probability of getting black pen, that is P of X, is equal to 8 by 10 equal to 4 by 5. And the probability of getting red pen, that is, we have the red pens, 2 red pens and 8 black pens. So 2 by 10, that is 1 by 5. So according to the definition of mutual exclusive, we know that event of getting a black pen and getting a red pen from the bag are known as mutually exclusive event. Now we have to find out probability of getting a black pen or getting a red pen. So according to the addition theorem, for mutually exclusive events, we get probability of X or Y is equal to probability of X plus probability of Y. So therefore, probability of X or Y is equal to 4 by 5 plus 1 by 5. That is 5 by 5, it is 1. So probability of getting a black pen or red pen, it is 1. Now, the king, queen and the jack of the clubs are removed from a deck of the 52 playing cards and then shuffled. A card is drawn from the remaining cards. Now you have to find out the probability of getting a heart, a queen, a club and 9 of red color. Now first, total number of cards in a deck, it's 52. Card remove king, queen and jack of the club. Therefore after that, remaining cards are 49. And therefore number of favorable outcomes will be 49. Now first one is heart. Number of hearts in a deck of the 52 cards. There are 13 number of cards. The probability of getting a heart is probability of A is equal to number of favorable outcomes divided by total number of possible outcomes. We have total number of possible outcomes 49 and favorable outcomes are 13. Now next one is that a queen. Number of queen. Since club's queen is already removed. So here probability of getting a queen T, that is 3 by 43. Again same, our formula will be probability of A is equal to number of favorable outcomes divided by the total number of possible outcomes. That is 3 by 49. Now club. Number of clubs in a deck of the 52 cards is 13. And according to the question, king, queen and jack of the clubs are already removed from the deck of the 52 playing cards. So here total number of clubs are 13 minus 3, that is 13. And the probability of getting a club is 10 by 49. Now next is 9 of red color. Cards of hearts and diamonds are red colors. Now card 9 in each suit. Hearts and diamond 1. Therefore total number of 9 of the red color is 2. Therefore the probability of getting 9 red color is 2 by 49. Now next question is that a card is drawn from a well shuffled pack of 52 cards. Now find the probability that the card drawn is a red face card, neither a club nor a spade, then neither an S nor a king of red color, and neither a red card nor a queen, and neither a red card nor a black king. Now first one, total number of cards in a pack of well shuffled cards, that is 52. First one is that a red face card. We have to find out the red colored face card. Cards of hearts and diamonds are red color cards. Number of face cards in the heart, that is 3. Number of face card in diamonds, that are 3. And the total number of red face card out of the 52 cards, that is 3 plus 3, 6. So therefore the probability of getting red face card 6 by 52, that is 3 by 26. Then neither a club nor a spade. Number of clubs is 13. Number of spades 13. Number of club and a spade, that is 13 plus 13, 26. Number of card which is neither a club nor a spade, 52 minus 26, that is 26. And therefore probability of getting neither a club nor a spade, that is probability of A, number of favorable outcomes divided by total number of outcomes, 26 divided by 52, it is 1 by 2. Then third condition is that neither an S nor a king of red color. Number of S in a deck cards, that is 4, and the number of king of red color in deck 52, that is 1 diamond plus 1 heart king, 2. And the number of ace and the king of red color, 4 plus 2, that is 6. So number of card which is neither an S nor a king of red color, 52 minus 6, that is 46. And therefore the probability of getting neither S nor a king of red color. So probability of A is equal to number of favorable outcomes divided by total number of possible outcomes, that is 46 divided by 52. Now fourth one is neither a red card nor a queen. Number of hearts in a deck of 52 cards is 13. Number of diamonds in a deck 52 cards, 13. The number of queen in a deck 52 cards is 4. And the total number of red card and queen, that is 13 plus 13 plus 2, that is 28. So after that, queen of the heart and queen of diamond are removed. So here number of cards which is neither red color nor a queen. 52 divided by 52 minus 28, that is 24. So here probability of getting neither red card nor a queen, probability of A is equal to number of favorable outcomes, total number of possible outcomes, that is 24 divided by 52, 6 by 13. Then fifth condition is that neither red card nor a black king. So number of hearts in deck of 52 cards is 13. Number of diamonds in deck of 52 cards, 13. Number of black king in deck of 52 cards, that is 1 king of spade and 1 king of club, equal to 2. And the total number of red card and black king is 13 plus 13 plus 2, that is 28. So number of card which is neither a red nor a black king, 52 minus 28, again that we will get the 24. And now again we have to find out the probability neither a red card nor a black king. So 24 by 52, that is 6 by 13. So this is all about the problems on mutual exclusive. These are the references, so you can go through this. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.